High amperage readings on the grounds of 3-phase 480 volts large industrial compressor units coupled with low voltage readings and a lack of amperage on a steel beam indicate a potential ground fault issue. It is crucial to identify and address the root cause to ensure safety and prevent equipment damage. Here are several possible causes to investigate. Firstly, a faulty grounding system. The grounding system may not be properly connected or could have high resistance, resulting in insufficient grounding. To address this, check the integrity of the grounding conductors, connections, and bonding. Secondly, an open ground fault. An open ground fault occurs when the grounding path is broken. This prevents current from flowing to ground, potentially leading to high ground fault currents and electrical hazards. To verify this, use a continuity tester to verify the continuity of the grounding path. Thirdly, broken or loose neutrals. In a 3-phase system, the neutral conductor provides a path for ground fault current. A broken or loose neutral can interrupt this path, thus causing high ground fault currents. Ensure that you check the neutral connections and ensure they are tight and secure. Fourthly, high leakage current. Leakage current can flow through the insulation of electrical components, causing a voltage drop between the live conductors and ground. In high-power systems, this leakage current can be significant, resulting in low voltage readings on the grounding system. It is recommended to have an electrician inspect the electrical equipment for any signs of insulation damage or excessive leakage current. Fifthly, measurement error. Ensure that the ammeter and voltmeter are properly calibrated and connected correctly. Use a clamp-on ammeter to measure the current on the grounding conductors without touching them. Here are some steps to troubleshoot the problem. 1. Inspect the grounding system for any visible damage or loose connections. 2. Test the continuity of the grounding path using a continuity tester. 3. Check the neutral connections for tightness and security. 4. Have an electrician inspect the electrical equipment for high leakage current. 5. Verify the calibration and accuracy of the measurement equipment. Remember that working on electrical systems can be dangerous. It is always best to have a qualified electrician perform any electrical troubleshooting or repairs. A properly functioning grounding system is essential for electrical safety and equipment protection. High ground fault currents can indicate a serious problem that needs immediate attention. Ignoring these issues can lead to equipment damage, electrical shock, or even fire. Thoroughly inspect all grounding connections. Check for corrosion, loose connections, or damaged conductors. Ensure that all grounding conductors are properly sized and installed according to the relevant electrical codes. Use a ground resistance tester to measure the resistance of the grounding system. A high resistance indicates a problem with the grounding path. Compare the measured resistance to the acceptable limit specified in the electrical codes. If the grounding system is found to be faulty, make the necessary repairs or replacements to restore its integrity. Pay close attention to the neutral connections in the 3-phase system. A loose or broken neutral can create an imbalance in the system, leading to high ground fault currents. Tighten all neutral connections and inspect them for any signs of damage. If a neutral conductor is broken, it must be replaced immediately. Leakage current can be difficult to detect without specialized equipment. An electrician can use an insulation resistance tester, also known as a megometer, to measure the insulation resistance of the electrical components. A low insulation resistance indicates a high leakage current. If excessive leakage current is detected, the affected component should be repaired or replaced. Ensure that the ammeter and voltmeter being used are properly calibrated. An inaccurate meter can lead to misdiagnosis and incorrect troubleshooting steps. Compare the readings from different meters to ensure consistency. If there is any doubt about the accuracy of a meter, have it calibrated by a qualified technician. When measuring current on the grounding conductors, use a clamp-on ammeter. This allows for non-contact measurement, which is safer and more convenient. Ensure that the clamp-on ammeter is properly zeroed before taking measurements. Be aware of the potential hazards of working with electrical systems. Always de-energize the equipment before performing any troubleshooting or repairs, if possible. If it is necessary to work on live equipment, use appropriate personal protective equipment such as insulated gloves and safety glasses. Follow all safety procedures and guidelines. If the problem persists after performing these troubleshooting steps, consult with a qualified electrician. They have the expertise and equipment to diagnose and repair complex electrical problems. Remember that electrical work should only be performed by qualified individuals. Never attempt to perform electrical work if you are not properly trained and experienced. Improper electrical work can be dangerous and may violate electrical codes. Regularly inspect the electrical system to identify and address potential problems before they become serious. This includes checking grounding connections, neutral connections, and insulation resistance. A proactive approach to electrical maintenance can help prevent equipment failures and electrical hazards. Keep accurate records of all electrical inspections, tests, and repairs. This information can be helpful for future troubleshooting and maintenance. Ensure that the electrical system is properly documented, including wiring diagrams and equipment specifications. Grounding is essential, especially in large industrial equipment. A good ground diverts stray currents from the chassis of the equipment and prevents electrical shock if someone touches the equipment, while it might have a short circuit. If the voltage from the chassis of the equipment to ground is more than just a few volts, then that is an indication of a grounding problem. If the equipment is properly grounded, a short circuit to the chassis will trip the breaker right away. The higher the amperage reading to ground, the greater the electrical hazard, and the greater chance of something going wrong. Always use a meter that is rated higher than the voltage of the equipment that you're testing, in this case 480 volts. A meter rated for 600 volts is perfect for this situation. Make sure your meter has a category 3 or better rating. Also, to be clear, grounding is usually a wire connected to a rod that is driven into the earth, close to the building. Bonding is the connection of all metal parts of the equipment together, so that they have continuity to ground, in the event of a short circuit to the chassis. The first thing is to visually inspect the grounding system. Look for loose connections, corroded wires, or broken wires. If you find any problems, fix them right away. Make sure that the grounding wires are the correct size. The size of the grounding wire depends on the size of the circuit breaker or fuse that protects the circuit. Consult an electrician for the correct grounding wire size. Check the resistance of the grounding system. The resistance should be as low as possible, preferably less than 1 ohm. You can use a ground resistance tester to measure the resistance. If the resistance is high, there is a problem with the grounding system. Common issues are corroded ground rods, loose connections, or broken wires. Another possible cause of high amperage readings is leakage current. Leakage current is current that flows through the insulation of the equipment to ground. This can be caused by damaged insulation, moisture, or dirt. You can use a leakage current meter to measure the leakage current. If the leakage current is high, there is a problem with the insulation of the equipment. Common issues are damaged wires, wet components, or dirty components. It is important to find and fix the source of the leakage current. Otherwise, it can cause a fire or electrical shock. The ground wires and the equipment should be properly bonded together. This means that all of the ground wires should be connected together with a bonding jumper. The bonding jumper should be the same size as the ground wires. This ensures that the equipment is properly grounded and that there is a low resistance path for fault current to flow. If the bonding jumpers are loose or corroded, they should be tightened or replaced. It's possible that you're not getting a good reading on the steel beam because it is not properly grounded. You can try connecting a ground wire from the steel beam to a known good ground. This will help to ensure that the steel beam is properly grounded and that you are getting an accurate reading. Before touching anything, turn off the power to the equipment. This will help to prevent electrical shock. Use a voltmeter to check that the power is off before touching anything. If the power is not off, do not touch anything. Call an electrician to turn off the power. Visually inspect the equipment for any signs of damage. Look for loose wires, corroded connections, or broken components. If you see any damage, do not touch the equipment. Call an electrician to repair the damage. Always follow safe work practices when working with electricity. Wear safety glasses, gloves, and shoes. Do not work alone. Have someone nearby who can help you in case of an emergency. If you are not comfortable working with electricity, call an electrician to do the work. It is better to be safe than sorry. If you don't understand how to do something, ask someone for help. There are many resources available to help you learn about electricity. Consult an electrician, read books, or take a class. There are many things that can cause high amperage readings in the ground of electrical equipment. It is important to troubleshoot the problem carefully to identify the root cause. Once you have identified the root cause, you can take steps to fix the problem and prevent it from happening again. High amperage readings to ground are dangerous. They can cause electrical shock, fire, and equipment damage. It is important to take these readings seriously and to troubleshoot the problem right away. Here is a recap of some common causes and solutions. Faulty grounding. Look for corroded or loose wiring, especially at junctions. Also, ground rods can corrode over time. Replace ground rods if they are too corroded. Open ground fault. Test the continuity of the ground wire and search for breaks and repair any broken wires. Broken or loose neutrals. Ensure that the neutral wire is properly connected and not broken and replace as necessary. High leakage current. Test the insulation of the wires and equipment to see if there is excessive leakage. Replace any damaged wires or equipment. Measurement error. Confirm that your meter is working correctly and that you are using the meter correctly. It's also important to check the voltage and amperage readings at the source, that is, the electrical panel, to verify that everything is working correctly at the source.